Hi guys, welcome back to the channel. Jag here, and in today's class we're going to continue with our grade 10 math content, and we're looking at solving the quadratic equations. And what I wanted to focus on today was some of the application questions from the textbook. So with that, let's get started. Okay, let's try this question here. So it says a rectangle has dimensions x plus 10 and 2x minus 3. So I'm going to just sketch that out here. Okay, so this is my rectangle. Again, always make sure you're drawing out a diagram, okay, so you can actually visualize it. Okay, so this is the length, and maybe this is the width here. Okay, and the reason the bottom part is the width with 2x minus 3 is because you're subtracting, okay? This side is most likely going to be the shorter side, okay? And determine the value of x that gives an area of 54 centimeters squared, okay? So what we're going to do here, I'm going to write the formula for the rectangle, which is length times width, okay? The area is 54, so I'm going to plug in the 54 here, equals the length, which is x plus 10, and the width, which is 2x minus 3. Okay, does everyone see that? So we are just plugging in all of these unknown values into the formula for the area of a rectangle, okay? So what we're going to do here, okay, is keep the area the same. I'm going to expand and simplify using the FOIL method. So we're going to do here, so let's just keep 54. 54 equals, we're doing x times 2x, okay, so 2x squared. And then x times negative 3, so this is going to be negative 3x. Then I'm going to go to the inside two values or numbers here. I'm doing 10 times 2x, so this is going to be plus 20x. And then 10 times negative 3, okay, which is negative 30. So I can see that the numbers are kind of big here, okay? But don't worry about that. We are just going to collect the like terms, okay, together. And just try to simplify everything together first, okay? So I'm going to put 54 equals 2x squared. Okay, we're going to do negative 3 plus 20, positive 17x minus 30. Okay, is everyone with us so far there? Okay, so in the next step, we're going to take the 54 to the other side. You see how it's positive 54? And on this side, it's going to be negative 54, okay? So we're doing negative 30 minus 54, okay, which is negative 84. So I'm going to rewrite the equation right here. Plus 2x squared plus 17x, okay, minus 84, which is equal to 0, okay? And so what we're doing here is I have my final equation. So we're going to, again, take some products of 84. And try to take some larger numbers here, okay? So let's rewrite the equation here, okay, at the top. So I'm going to take out the top part here, okay? So this is our equation. I'm going to write it at the top. So 2x squared plus 17x minus 84 equals 0, okay? And so the reason is this is a complex trinomial, right? We can see that. Okay, we have to do actually 84 times 2, and I can see this is a really big number, okay? So the product is negative 168. Make sure you're doing 2 times negative 84 here, okay? And I can see that the sum is going to equal to positive 17. When you're taking the factors here, okay, make sure you're taking some really big numbers. Okay, and that way you can see if you're getting the actual answer. All right, so 168, and we're going to try dividing it by several numbers here. Okay, 168 has several factors. Okay, so say I divide it by 6. Okay, and I have to get negative 168. Okay, so maybe something higher than that. Okay. Perhaps 8 or 4. Again, I would take some bigger numbers, okay? So I'm trying to divide it by 9. Or even if you can, divide it by 12, okay? I don't want to actually add the two numbers together, okay, to get my answer. And so we can use 14 is a factor, okay? 8 is also a factor here. Okay, and let's try maybe something smaller here. So maybe like 6. Okay, and 14. So again, if I can't find the factors right away, okay, what I would do here is just put it into the quadratic formula. Okay, so we will go through the quadratic formula one more time. Okay, so this is the value here, so -7. Let me write out the formula here. Okay, so it's b squared minus 4ac over 2a. Okay, and again, there will be upcoming videos again to make sure we go through the quadratic formula. If you're not sure how to use the formula, okay, you can check out one of my previous videos. And the reason we're doing the formula here is we don't want to really waste time looking for factors, especially if the numbers are really big, okay? So I wouldn't do that, okay? So the b value here is negative, so put negative b. So -17 plus or minus, okay? And this is going to be actually -17 squared, so 289 minus 4 times a times c, okay? And the c value is -84. And the whole thing is over 2a, okay? So I'm going to write the answer on the side here, okay? Okay, so we're going to do 289. And right here, you see that there are actually 2 negative signs here underneath the brackets, okay? So we're going to actually add these numbers together. We are getting 961 over 4, okay? And I'm just going to write out the 2 values, okay, for x that we're getting here. So 961, the square root is 31. So -17 plus 31 divided by 4. So x is 3.5, okay? Or I can do -17 minus 31 divided by 4, okay? And x is equal to -12. Okay, so I'll just write that a little bit higher so we can see it. So these are basically my 2 values of x, okay? And it just says to determine the value of x that gives the area of 54. So in this case, okay, so it was -17 minus 31. So this was actually -12, okay? And because we're dealing with area here, okay, if you get a negative number, we're not going to use that number, okay? So I'm just going to cross that out. And the value for x we're going to use is 3.5, which makes sense as well, okay, in terms of the question, like 3.5 centimeters. And when you're plugging it into the length will be 13.5 centimeters, okay? And if I'm looking for the width, I'm going to do 2 times 3.5 and minus 3, which is equal to 4 centimeters. Okay, so my numbers can be really big, especially when I'm dealing with the area or the width of a rectangle. Whether or not it's like a fence or something like that, make sure your values for x are pretty small in terms of the width. Okay, are there any questions there? All right, so you could actually find the factors, okay, for 168. I wanted to just show you how to do it with the quadratic formula, and you can see that it took us only about like 2 minutes to get the answer right away, okay? When you do go through the application questions for the quadratics unit, okay, we are always applying the quadratic formula. We are not going to actually factor out these values because it's just going to take too long to find the answer for each question. All right, so with that, let's go to the next question here. So let me just take this off. Okay, and the next question is going to be you coming up with the quadratic equation. So I'm going to read out the question. It says, write a quadratic equation in the factored form for each situation. Okay, so in the first one, it's going to be the roots of the equation are 5 and 4. Okay, so when it says the roots are 5, it's x equals 5. And the root is also x equals 4. So what they're giving you in this question is basically the x-intercepts. Okay, what we're going to do is we're writing it in the factored form. Okay, and this is actually the factored form of the quadratic equation. So it's y equals a bracket x minus r and x minus s. Usually just put the negative sign here, okay? When the x-intercepts are given, we're just going to change the signs. So I'm going to put y equals x minus 5 and then x minus 4. Okay, some students do get confused and they forget to change the signs here, okay? Inside the brackets, it's not going to be x plus 5 and x plus 4. I have to make sure I'm changing the signs back to negative. Okay, are there any questions? Okay, so let's try B as well. Here the roots of the equation are given, so let me just take this off. Okay, so this time the roots of the equation are going to be negative 2. So I'm going to put x equals negative 2 and x equals 3. Okay, and again we're just writing the equation in the factored form. So let's do y equals a, and then we're going to put x plus 2 because it's negative 2 here. And because x equals 3, we're going to change the sign again. It's going to be x minus 3. Okay, so in this question, you're probably wondering what the a value is. The a value tells you whether or not the quadratic function is a stretch or a compression. In this question, there isn't enough information given, okay? So we're going to just assume that the a value is equal to 1. And that means that there is neither a vertical stretch or a vertical compression. And as we go through the contents, we will be going through how to calculate that as well, okay? But for the purpose of this question, we are just going to change the signs and assume that the a value is equal to 1, okay? If the a value was greater than 1 or less than 1, the question would give you more information, such as like the vertex or another point that actually lies on the quadratic function. And that way you would be able to plug it into the equation and solve for the unknown value of a. Alright? Alright, so if there are no questions, that brings this video to an end. Thank you for watching, and please make sure you are subscribing to the channel and click on the like button below because it makes a really big difference. And I will see everyone next time. Thanks, bye.